is trying to stream this video, teaching video. This is testing to make sure that everything is clear, the sound, the video, everything is so clear. All right. Good. So we're going to actually solve some questions on computer networking. Yes. I welcome you back once again. We're still having some hitches trying to work on things so that the live stream will be clear and with quality video so that we don't have some questions on computer networking. So let's go straight to the questions. So the first question is, if in CIDR notation of an IP address is written as 172.26.17.1/25, what is a subnet mask? What is a subnet mask? So if you have been given an IP address with a CIDR notation of 172.26.17.1/25, how do we find a subnet mask? All right, so let's do this. So we have 172.26.17.1/25. So this is a CIDR notation. All right, so this we need to write the CIDR notation in binary form. All right, so this will be, in fact, this address is an IPv4 address. And therefore, if we are supposed to write an address in IPv4 form, we will need 2, 3, 4, 5, 6, 7, 8. That's the first octet. That's 8 bits. Then the next octet, 1, 2, 3, 4, 5, 6, 7, 8. That adds up to make 16. Then we have 1, 2, 3, 4, 5, 6, 7, 8. That adds up to make 24. Then we need one more here. Then the rest 0, 0, 0, 0, 0, 0, 0. So that makes it 32. So in all, for IPv4 address, IP address is supposed to be 32 bits. So with this CIDR of /25, we just have to make, the bits one. This is where the 25 ends. And all that we need to do is to convert these bits into decimal numbers. Will be, when you convert these ones into decimal, you have 255. We're going to have 128. I have a small converter here. Not to waste time solving this mathematically, I just have a converter. Decimal gives me that. So it means that my subnet mask of this IP address of the network on which we have this IP address is 255.255.255.128. All right. All right, let's move to our next question. So which class does the IP address 192.168.10.5/24 represent? Which class does this IP address 192.168.10.5/24 represent? In networking, we have network classes. We have network class A, class B, class C, class D, and so on. We have their subnet mask. The class A has subnet mask of 255.0.0.0, and class B has 255.0.0.255.0. So we can determine where that, in fact, CIDR means classless interdomain routing, where we don't really look at the class. Okay, we can form different, we could have, as it was given to us, /24. And that's what we are going to work on. We're going to look for the class. In fact, /24 is just one of these classes. Okay, so we have 192.168.10.5/24. All right, so with this one, clearly we can say that it's a class C network. Now let's find out why it's class C network. When we write down the CIDR, we'll have, this IPv4 address, IP address. So we have 4 octets when we convert the IP address into binary. So with the 24, we count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 0, 0, 0. All right, so for an IP address, IPv4 IP address, when we convert the IP address into binary, we are going to have 32 bits. In 4, we are going to have 255. This one too, you have 255. When you convert this, you convert that. This also, you're going to have 255. And this, you're going to have 0. So clearly, you can say that. So this is a subnet mask. So clearly, you can say that this is a class C network. There's a class C network. All right, let's go to our next question. Question number 3. All right, so the question says that your router has the following IP address on the Ethernet 0 port of IP address 172.16.2.1/23. That is the CIDR notation. Which of the following can be valid host ID or IDs on the LAN or local area network interface attached to the router? So the question is just asking us to check all these 4 IP addresses, whether any of them lies in the network that the router is on. So there are a few things that we are going to do. We are going to first look for the network itself. Then we are going to look for the number of IP addresses that are supposed to be on the network. Then we'll check if any of these are in there. So we have an IP address on a network or a router on a network using the IP address 172.16./23. All right, so we are going to first look for the network, and the CIDR will help us to really know how the subnet mask will look like, and also help us to get the network itself. So with the CIDR, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. That makes it 16. 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. So 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we have 16, 17, 18, 19, 20, 21, 22, 23. All right. 1, 2, 3, 4, 5, 6, 7. Okay, 8. Then we are going to convert this into binary. And when we do this, what we'll have 172 is 10 10 11 00. Then we have dot 16. 1, 2, 3, 4, 5. 0, 0, 0. 1, 2, 3, 4, 5. Then we have 2. When we convert 2 to decimal, 2 to binary, we have 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 1, 0. Then when we convert 1 to binary, we have 0, 0, 0, 0, 0, 0, 0, 1. And for us to get a network, we are going to use the AND operator, And this is how it works for the AND. You have 1 and 1, then you have 1. If you have 0 and 1, you have 0. If you have 1 and 0, you have 0. If you have 0 and 0, you have 0. So the only way that you have 1 is when you have 1 and 1. Okay, so 1, 1 is 1, 1, 0 is 0, 1, 1 is 1, 1, 0 is 0, 1, 1 is 1, 1, 1 is 1, 0, 0. In fact, wherever there are ones, they will repeat the same thing, 0, 0, 0, 1, 0, 0, 0, 0. We have 0, 0, 0, 0, 0, 0. 1, 0, then we have 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we are going to convert this one into decimal, and because it's the same, the value will not change. It's still 172. This one is still 16. This one, let's check if there have been some changes. It is still 2. There has not been any change. And here we have 0. So it means that the network itself, or the network ID, is 172.16.2.0. Now we're going to look for the number of IP addresses that can be on this network, and this is how we look for them. If you look at the CIDR notation converted to binary or bits, after all the ones following each other, the remaining zeros actually will show us the host ID. Host IDs, or IP addresses that could be assigned on the network. In fact, we know that for every network, on this network, this one is not usable. Then we have the last IP address on the network, which is the broadcasting IP address, or the broadcast /23. After counting 23, the remaining that are 0, they will actually help you. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that we have 2 exponent 9. And that should tell us the number of IP addresses that will be on this network. So 2 exponent 9 gives us 512. 512. By the usable actually IP addresses will be 510. Okay, that is -2. But this is what we are looking for. So these are the number of IP addresses that are on the network 172.16.2.0. And let's check if we have any of these ones on the network. Let me even write all the, the range of IP addresses. So the range of IP addresses on the network will be 172.16.2.0 to 172.16.2.0. 255. Okay, so we have 512 minus, and we have to subtract 1 from it again, and it will remain 512.16.3.0 to 172.16.3.255. I have to subtract that. This actually is a broadcasting IP. Okay. All right. So let's see. We have a C on this network. 172.16.2.255. Yes, it's on the network. And 172.16.3.0 is also on the network. Let's check the answers. All right, so we can see 172.16.2.255 is on the network. 172.16.3.0 is also on the network. And there's an explanation that has been given. The router's IP address on the Ethernet 0 or O interface is 172.16.2.1 on a CIDR of /23 is having a subnet mask of 255.255.255.0. And now let me show you how that one was obtained. Now, how do we get our subnet marks like we did previously? Okay, you convert this one, the whole of this, to decimal, and you have what is it? This one. Then we use the CIDR to do it. So it will be 255. This one too is 1111110. From binary to decimal, we have 1, 2, 3, 4, 5, 6, 7, 0. That is 254. 254, and the last one is 0. So actually, this is a subnet mask of this this network. 255.255.254.0. Let's continue. All right, this makes the third octet a block size of 2. The router's interface is in the 172.16.2.0. All right, so that's the router's interface. It's on that, on the network 172.16.2.0. All right, and the broadcast address is 172.16.3.255. 172.16.3.255. And the next subnet will be 172.16.4.0, and the valid host range is from 172.16.2.1 to 172.16.3.254. I've told you that the first IP address, which is the 172.16.2.0, is a network, so we don't use it. It's not usable. Then the last IP address, which is 172.16.3.255, is also for broadcast and it's not usable. Now let's go to our last question. what is a network address, broadcast address, and the subnet mask of the network that includes a host with the IP address of 194.195.154.113/22. So there's a network, and we don't know the network, but we have an IP address on the network, and they want us to find the network ID. Did I say the network ID? The network itself. And there's the IP address of the network, and the broadcast IP address, which is actually the last IP address on the network, and the subnet mask. Okay, so let's do this. So one of the IP addresses on the network is 194.154.154.13/22. So this 22. Okay, so we are going to look for first the subnet mask. Okay, so this is an IP address on the network. One, two, three, four, five, 6, 7, 8. It's 252. I have 0. So that is subnet mask. Then we're going to also look for the network IP address, the network IP address. All right, so I'll continue from here. I'll use the same IP address on the network. So I'll convert it to binary, and this is what we have. Let me write the subnet max down here. So you have subnet max of 255.255.252.0. .194 to decimal is 194 to binary. 194 to binary is 11000010. Zero 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 11. Then 154 is 1010. 1001110. Then the last one, 113, will be 1 2 3 4 5 6 7. So we have 0 1 2 3 0 0 0 1. All right, so we are going to use the AND operator to get the IP address of the network. And the AND operator has this principle. 1 1 gives us 1, 1 0 gives us 0, 0 1 gives us 0, 0 0 gives us 0. So the only way we get 1 is when we have 1 1. So here we have 1 1, and we get 1 1 1, we get 1 1 0, we get 1 1 0 0 0 dot 0 0 0 0 0 0 0. Work IP address. We are going to convert these ones into decimal numbers. So this actually is not different from this, the same, so write the same. 194. This is also not different from this, so we have 195. Here there's something is different here. So we need to convert from binary to decimal. And here we have 1 0 0 1 1 0 0 0 100 1 1 0 0, and that gives us 152. And here we have 0. So this is a network. This is a network. The network IP address. The network IP address. Okay, like here, from here all the way to this point is a network ID. Is a network ID. And here we have the host ID. So from here to all the way to here is a network ID. I think I kept saying network ID. The network ID is where we have the ones and the zeros actually is the client ID or the host ID. But what we've looked for is the network IPS on this network, and we get it from here. From where the zeros are, from the network, the host IDs. Okay, 1, 2, 3, 4. Host IDs or the IP address will be the same as 2 exponent 10, and that gives us 1024. We know that for every network, there are 2 IP addresses that we don't assign. The network IP address and the broadcasting IP address. All right, so we can remove 2 here from here, but I don't want to do that. It's not necessary here. So we're going to first list the range of IP addresses. Use down here. Let me see. Okay, fine. So I'm going to write the range. Well, this one can come up a little bit. So the range of IP on this network. So all the way to 194.195.152.255. So in this case, the 1024, we've removed 255. And when we remove 255, we have to still remove 1, and it will remain minus 255 minus 1, 768. And here we'll start with 194.195.153.0, So we have added 255, so we're going to minus 255 minus 1, that gives us 51512. Then the next one, 154.0, all the way to 194.195.154.255. So we've taken 255 also from here. This will be the last subnet on the network, and is 194.195.255. We've subtracted another 255 IP addresses. 195.155.55. Let's check. The answer. All right, so our network address, our IP address is 194.195.154. Our network address is 194.195.152.0. 194.195.152.0. Our broadcast address is 194. That's the last one. That is 194.195.155.255. And our subnet mask is 255.255.252.0. All right, so we've come to the end of the lesson for today. We're going to have series of these. The sound is clear, the video is okay. iTagehome is actually a registered services, all registered, like other IT services like hardware, repairs and maintenance, or system administration, and other IT services. We've not commenced yet. As I said, iTagehome Enterprise is a registered information technology business. Our main, we'll be having, as I said, a series of training. If you are passionate for information technology, you should always join us on information technology